Well, after knowing the configuration types of processors, their connection options, and the purpose of controller services, we are ready to build our first real-world data flow. In this demo, we will request data from the Wikipedia REST API and write the responses to flat files, without applying any transformations so far. For this, the configuration of the controller services will be necessary, providing an SSL context in order to securely query the HTTPS endpoint. Once we have configured the required components, we will connect the processors and set the relationships accordingly. Alright, then let's drop the first processor, invoke HTTP onto our empty canvas, which can interact with HTTP endpoints, and allows to configure the destination URL and the HTTP method, among a bunch of other properties. After opening the configuration of the processor via double-click or right-click configure, we directly land in the Properties tab. Here we can see that the HTTP method is already set to GET, so no need to change. The remote URL is the actual endpoint of the REST API. In this case, we are requesting recent changes made on Wikipedia via the so-called MediaWiki Action API, providing a set of parameters already here. In simple words, this just means get the title, author, and time of the most recent change made on Wikipedia. As mentioned before, for a secure connection and in order to not face SSL errors, we will also configure a SSL context service. For this, we need to open the drop-down menu, select Create New Service, and choose the second compatible controller service. By entering the NiFi flow configuration through the little arrow sign, we can see that the controller service is still invalid, as it requires to populate the key store or trust store property. For demonstration purposes, we will just use the Java default values. The trust store file you can find in your local Java home installation directory in the lib/security folder. The default password is changeIt, and the trust store type is JKS. Once we applied these changes, we can see that it isn't invalid anymore. Now we just need to enable it, and from now on we are able to use this SSL context throughout the entire data flow. The last property I want to highlight in the current processor is the content type, which is populated with the system variable mime.type. This just means that the file type will be determined based on the URL, or rather the type of the incoming flow file. In our case, we are retrieving JSON files. Let's navigate back to the Settings tab. There you can give the processor a proper name, but more importantly to set the automatically terminate relationships. For sake of simplicity, we will only connect the response to our output file processor. That means the rest needs to be set to auto-terminated. After applying these changes, the processor status is still invalid. This is because the last relationship, response, isn't connected yet. Hence, we go on with dropping the destination, a put file processor, onto the canvas, for writing the flow files to the local file system. The properties here are quite self-explanatory, and for this demo, the minimum requirement is to set a valid directory path where the flow files are going to land. Even though this is actually considered as the end of our data flow, you could further pass on the files that could or could not be written to the output directory. But let's just enable auto-termination for these relationships. Now we can connect the processors to each other by enabling the only left response relationship in the Details tab. After clicking Add, the warning symbols of the processors should disappear, and the data flow is now ready to be started. We can either start all processors at once with right-click anywhere in the canvas, or directly on the desired processor for starting it separately. Let's start all at once. After refreshing the UI, we can see based on the statistics that data is already flowing through our processors. Let's stop the flow and look at our output directory. We can see it's filled with single files, named with the unique identifiers of the flow files, and each one contains only one record. By moving back to NiFi, we can also see that the one file is currently still queued. We can also view the content there. However, even though we have achieved what we wanted so far, we are not entirely happy with the data flow, as we actually don't like to have so many files in JSON structure and containing only one single record. We would like to have the data in a table-like structure, containing multiple records. Furthermore, we want to have more descriptive file names and remove potential duplicates. We will see in the upcoming demo how to apply proper file names, extract only a specific part of the JSON file, convert this to a CSV structure, delete duplicates by applying SQL code, and finally how to merge the content of multiple flow files. But before, we will get familiar with the Apache NiFi attributes and the expression language, as this will help us to achieve our transformations.